everyone. First, can everyone hear me? Is the sound all right? Or okay, perfect. All right, so thank you all for coming. So today I'm going to run a small presentation about Chainlink. So the few items I'll be covering will be smart contract connectivity. So basically, what is the main problem Chainlink focuses on solving in the blockchain ecosystem? Then I'll be making a small demo on how you can use Chainlink in your smart contract, how Chainlink supports the current DeFi ecosystem and the current kind of DeFi revolution which has been happening lately. And lastly, I'll be going over one new feature which we've been working on very hard in the last few weeks about trust minimized computation using Chainlink nodes and Arbitrum computation, Arbitrum rollups. All right, so first off, to kind of put things into perspective and so that we are all on the same context, currently the main issue we see in the blockchain industry is that it's a siloed industry, right? Blockchains have no access to the real world. They can't read real-world data, they can't read real-world events. They're basically siloed from this whole ecosystem of data that you have out there in the real world. And this data can be key on multiple levels, right? So this data can be financial data, it can be IoT data, it can be stuff that you can use for derivatives, for future contracts, for insurance, for supply chain. All of these great use cases are allowed by data. Basically, you need data in order for these use cases to evolve on blockchain, on Ethereum. So basically, what is our mission? We want to connect smart contracts to the real-world data. We want price data, for instance, for DeFi protocols, to be able to read the current price of ETHUSD, of BTC/USD, or any other asset like FX and commodity, right? In the case of synthetic assets, for instance, if you want to synthesize gold on Ethereum, you need the price of gold, the current price of gold, right? So we need this bridge. We need smart contracts to be able to read these values. We also want smart contracts to be able to access real-world payment methods. So that means being able to plug into PayPal, being able to plug into Swift, all of these payment methods which are necessary because not everyone is ready yet to adopt cryptocurrencies and to have payments made in crypto. So having access to the real-world kind of widely accepted payment methods is extremely important. And lastly, we want to be able to connect blockchains together. So it means basically having a Bitcoin transaction which is going to trigger a smart contract on Ethereum, for instance, or a smart contract on Ethereum which is going to trigger a Bitcoin payment or a Tezos transaction, right? So that's our goal. It's basically taking the current ecosystem we have, an ecosystem which is extremely siloed, which kind of resembles the days of the intranet, and making sure everything gets connected. So it's basically building bridges. I think the way you add value to an ecosystem like ours is by building bridges to other sources of data, like real-world data, real-world events, or other blockchains, for these blockchains to communicate between one and another. So how do we do this? Now, I think it's very important to take into consideration the security aspects whenever you're going to bridge your real-world data and events to Ethereum, right? So, for instance, whenever you are going to start creating smart contracts on Ethereum, it means you have some values that you want to have, right? You want decentralization, transparency, security, all of these great aspects which are necessary for a smart contract dApp, right? That's what DeFi has been built on. Transparency, decentralization, and basically having protocols which can run in the long term without having any central party which could take them down, right? Maybe it's not the reality today, but that's what we're aiming for, all of us, by building this movement. And the way you do this is by not having any central point of failure, right? So we don't want this critical piece of infrastructure, the oracle, to be centralized. We don't want it to be run on closed source code with only one single node, because it means that your smart contract would basically rely on faulty infrastructure and would have a centralized point of failure. So that's not something we want to have, right? So basically, the way we want to do things at Chainlink is by having decentralization, multiple nodes feeding data to an Ethereum smart contract. It's basically the same way we come to consensus with multiple nodes around the world which agree on the state of the blockchain. We want to come to consensus on the data by having multiple nodes around the world which come to consensus around the state of the data. right? So the price of ETH, the price of Bitcoin, the price of gold and silver. So now I'm going to run a small kind of demo on how you can set up a Chainlink contract so that it's a bit more expressive, right? So if you go to this link, basically you'll go to our documentation. In our documentation, we explain how to use a truffle box. So very simply, let's see. I'm just going to... I'm a bit paranoid. When I share my screen, I forgot to delete a bunch of stuff. So, all right. Now, I already set up a contract because the network, I think, is going to be a bit slow here, and Robson is also going to be slow. So basically what we're going to do is I have a truffle box which has already been unboxed. The instructions are in the documentation on how to do it. And that's what I get. So out of the box, I get a Chainlink contract, basically, which has multiple components. So I'll go over a few right now. The main one is really the create request to. It's basically the request which is going to send demands to a Chainlink node for data. So basically here, we are putting some arguments which are saying, I'm going to want to talk to this Chainlink node, so this Oracle node, basically. I'm going to send him this job ID. So the job ID is basically what's going to allow me to get a certain data point. I'm going to send him a payment. He'll have to access a URL, and he'll have to parse the data using this pass. And then we'll have a multiplication because we don't have any decimal number on Ethereum. So basically, we'll have to multiply using the times argument. So once we have the answer from the Chainlink node will basically call this fulfill function, which will which will return the data points that it went to fetch, right? Now, what I'm going to show, and I want to go over this presentation a bit quick because that's very basic, right? And we've already put some script to automate everything. So if you go to the README, whenever you start hacking using Chainlink today or tomorrow, you're going to have all the instructions there on how to get started, right? And you're going to be able to first run these two scripts, which I won't be running here for simplicity. It takes too much time right now with the network. And we are going to just run these simple scripts. So what this script does, which I just ran, it's going to basically fund our contract with some link tokens. So the way the whole network works is you have node operators which get paid in link token, which is basically the kind of lifeblood of the entire network, right? And if you want to see how to choose a node operator, we actually have a marketplace for people to easily choose which node operators they'll be choosing, right? Which node operator is going to fetch data for my critical smart contract. So if you have a smart contract which has many millions of dollars relying on it, then you need to make sure that you have the best node operators out there to fetch you the data you need, right? So you can go on the marketplace, the Chainlink marketplace. You already have 109 node operators which have been basically listed there. And you can choose which node operator will fit your use case, right? So basically, if you go to the nodes page, you can see multiple node operators. Some of them have been security reviewed, which means the Chainlink team has checked basically their setup, has checked if they have enough redundancy, if they have monitoring systems around their whole system. And basically, these people are currently running on the Chainlink network. They're currently fetching data for live users of the network, right? Now, that's basically how you choose a node operator. So if I go to one of these pages, I have all the information I need. So I can see, for instance, that the node has been verified, which means they've been security reviewed by the team. We can see basically that they're listed on the Explorer, so we have multiple information points. We can see which adapters they're running, which means which data point they can fetch for your DApp. So you have multiple informations you can have from this. Actually, that's the link for the market.link if you want to access it after. I recommend you guys to go and check it out. If you have any questions, we'll be at our booth. So now, coming back to the demo. Once we funded the contract, we are able to send a request for data. So here in this request, what the script does is extremely simple. We are just fetching the price of ETHUSD, basically live from a Chainlink node, right? So if I go to request data, I can see what this data point is. So we are fetching the price of ETHUSD, we are multiplying this price, and we're returning it on chain, basically. Very simple. So once it's done, we can go to the Chainlink Explorer actually and check what's the state of the node fetching the data, right? So here we go, basically, and okay, sometimes it takes a bit of time. I think Robson is a bit slow also. All right, here we go. So yeah, that's the state of the node operator who is fetching the data live, right? So you can see the multiple operations he's doing. He's doing an HTTP GET. He's parsing the data that he fetched. He's then multiplying it because, as I said, Ethereum doesn't support decimal numbers. He's returning it to the blockchain after. And whenever you're going to read this data point, you're just going to be able to send, to use the last script, which is basically a read contract, which is going to read the value that the node operator returned. So, yeah, here you have the price of ETHUSD. Congratulations, seems like it's improving. So, yeah. That's basically how you can easily set up a truffle box, how to fetch the price of ETHUSD using our script. Now, that's really basic, right? Now, what can we do with this kind of stuff, which is really interesting and which can really help the DeFi ecosystem grow and can the ecosystem grow in general? Well, let's see what a contract, what a Chainlink contract can basically give you. So that's a reference contract, which is fetching the DAI ETH pair using multiple node operators. So on this contract, we have 7 operators, which are fetching the price of DAI, the trading pair DAI ETH, using 7 different data aggregators. So these aggregators can be Kaiko, BNC, CoinMarketCap, CryptoCompare, etc., right? And basically the way it goes is we have all of these decentralized networks, like we have one for DAI ETH here. We have multiple ones which are being set up and which are currently being used in production by DeFi dApps. The way these DeFi dApps use them are extremely versatile. So basically these 29 reference contracts are being used to mint synthetic assets, are being used by DEX protocols such as Loopring to secure staking, are being used for Ampleforce for the commodity money they have. So basically Ampleforce, for instance, has an elastic supply of money and they need to check the price of the Ample token in order to decide the supply of their token, right? And Aave, which is a lending and borrowing protocol, which has been using 15 of our feeds to basically secure their collateral. So, yeah, basically we've been seeing multiple use cases pop up in the space. Every DeFi dApp right now, as of today, needs price feeds, right? And the way they access these price feeds is extremely important. Now, if you build a dApp on Ethereum, you are not recreating the whole underlying infrastructure on which your dApp resides, right? You're not recreating the whole blockchain. You're basically building something on Ethereum. Well, we believe that if you want to access data, you shouldn't build the whole underlying Oracle infrastructure. You should be able to use a network which can provide you this data. And this network right now is Chainlink, which can provide you more than 29 reference contracts, prices for any data you guys would need. And basically, if you go to this page, we have all of these contracts currently listed. So ETHUSD, BTC-USD, we have networks for each of them. We have the users who are, the network is a bit slow. Okay. We have the users who are using them also live for the dApp, right? So here you can see the price of ETHUSD being aggregated. And yeah, who is using the network right now? So if you have any interest in a reference contract like this one for your dApp, if you need, for instance, the price of gold, the price of silver, or anything else, we'll be more than happy to talk to you and to support you in setting up a network like this. We've been doing this with these 4 applications. With Aave, we went live with more than 15 contracts which they needed. All of these are here in less than 2 weeks, and it was actually during Christmas, which means we had a very fun Christmas, you know. But yeah, if you need something, we'll be able to support you in setting up these networks. That's what we do. You know, that's basically how we want to support the DeFi ecosystem. We believe that oracles are extremely important because they can trigger liquidations, they can trigger margin calls. If your oracles are not secure and are not decentralized or transparent, then your whole system is at risk, basically. All right, so now going on to the next topic, which I'm extremely excited about. Currently, we've been working for some time on off-chain computation with our good collaborators from Arbitrum. Basically, we believe off-chain computation is key for the Ethereum ecosystem to scale, right? If you take the case of DeFi dApps, for instance, in order to embed complexity into a DeFi dApp, like complex financial instruments right now cannot be coded onto a DeFi dApp without having extremely high gas costs, right? It's not an easy matter to code up extremely complicated systems onto Ethereum right now. And that applies for DeFi, that applies for gaming, that applies for enterprises use case. You need scalability, you need privacy, you need all of these key components, right? And at Chainlink, what we've been working on is actually being able to have these node operators, which I showed you earlier, on this marketplace, be able to compute these extremely important pieces of computation off-chain and return on-chain a provably secure result. Now, how is this result provably secure? Well, basically the way Arbitrum computations work is they're being ran by Chainlink node operators. These Chainlink node operators will basically offer the reputation right behind them, like they're basically node operators who are running operation like blockchain infrastructure operations of multiple millions of dollars of value around the world, right? And basically the way Arbitrum works is that you have game theoretic and crypto economic guarantees behind it. Crypto economic guarantees comes from the staking that node operators put up, which means I'm a node operator, I put up a certain amount of collateral, a security deposit, whenever I'm going to process a computation, right? It's basically, I'm putting something at stake to say, hey guys, here I have maybe $500,000 of stake on the blockchain. If my computation is proven to be wrong, or is proven to be malicious, or my node went down, well, I'm going to be losing some money. And the game theoretic incentive is basically the way Arbitrum works, and kind of the protocol we've set up works, is you have a user contract, which is going to send a solidity function to be computed by Chainlink nodes. This function will be picked up by the Chainlink nodes who will basically compute it off-chain. They will then return a result on-chain. This result will be attached with a cryptographic proof, right? And whenever they return these results on-chain, there is an arbitration period where other Chainlink nodes can basically confront the result which was put up, because they also have a cryptographic proof, and they can basically confront the proof which was put by the other node operators, right? So there is an arbitration period which will basically determine the real result of this computation, right? Now, that's basically how it works right now. What we've been doing with Arbitrum is still quite at an early stage, right? So we've been working on it for a few months now, but we really hope that in the coming weeks, 2 months, we'll be able to show some things that can be used by DeFi dApps in production to basically scale up their application and to dramatically lower the gas costs they have to pay on-chain right now. So for the demo that I have, I'll be sharing my screen actually with one of our devs, Spook, who is going to be able to show you from his screen how it works, basically. Go for demo. All right, so we're just communicating like this for... all right, and I think we should start any moment now to share screen. All right, perfect. So, yeah, basically here, as you can see, Spook is showing you the UI for a job ID. So that's for a node operator, basically, who has his job ID here. Now, if he goes to the JSON page, you can see the JSON spec that the node operator will be running, right? So basically, the operator is making an HTTP GET request to the CryptoCompare API. He's then going to parse the data he gets. He'll be taking a subset of this data, and he's going to execute an API code of a solidity function here in this part that Spook is showing. And then basically, so that's an Arbitrum computation. As you can see, the type is Arbitrum, and the result, he's going to then return the result of this computation on-chain, basically. So what the computation does very simply is that it compares the number of transactions which happened on Bitcoin between two blocks. It's a very simple computation, just as a demo use case. That's the Solidity code which we are processing here and which was translated into API. So now I think we can get started with the demo. So we are going to fund the contract as we showed a bit earlier. And that part is a bit slow. That's why I avoided having too many transactions on testnet during the demo. Right, so here we're funding the contract. Then we are going to request the data. So request data is going to basically execute the job spec I was showing you guys earlier. And this one is going to be taking a bit of time because the way it goes actually is that there will be a computation which is going to be done on the Arbitrum node and which would take a few seconds basically. And knowing that the testnet is a bit slow right now because everyone is hacking, it might not be. But yeah, we'll get through it. So the good thing is that you can see the job being processed live using the UI. So here's the job which is being processed by the nodes. You can see the state live, like where is it right now? The HTTP GET, the parsing, and basically the Arbitrum computation. So probably if we refresh the page, we should be able to see, oh, here's the Arbitrum picked up the computation. So yeah, we are basically computing right now. All right, and you can see on the screen that Arbitrum is basically doing the computation for the job spec we sent it. All right, message delivered. Okay, so it's in the process of getting done. By the way, just by curiosity, could anyone who knew Chainlink before this presentation raise their hands just for a small opinion poll? All right, so one person. Okay, so not too many people knew Chainlink. All right. And then I think we should be done. So could we check again the UI just to see where we are? I think we're still at the computation, but just in case. All right. Okay, so computation is still ongoing. Right, so as you can see, it takes, again, a bit of time. That's always the issue in these hackathons. I'm done with demos, guys. All right. Okay, the computation is done. So now it's going to return the result on-chain. So this should be pretty quick. And then we can read the data and see how many transactions were processed between the two Bitcoin blocks that we sent, basically. All right, so it's on-chain now. And if we run the script to read the data, let's see. All right, so there you have the number of Bitcoin transactions run. So it's basically 31,000. So yeah, this use case was really to demonstrate how we can use off-chain computation in an application on Ethereum right now, as of today, right? So we are still in the process of we're still in the early stages of this. However, we were extremely excited because right now, as I discussed before, we have so many great use cases that we could build into Ethereum, right? Expand the use cases, the areas covered by DeFi, expand what you can do with games on Ethereum, expand the enterprise use cases, and all of this needs off-chain computation to scale right now. So Chainlink will be working on it in the coming months with the Arbitrum team, and basically, hopefully in the next few months, we can provide the current DeFi ecosystem and the current gaming ecosystem and any other dApp on Ethereum a reliable way for people to compute Solidity code off-chain and return the results on-chain in a seamless, trustless manner. So thank you very much for hearing me out. Our goal at Chainlink is really to scale up the ecosystem, to help the growth of the ecosystem, providing data, providing off-chain computation, and many more tools to come to basically become the abstraction layer, which will really allow the dApps on Ethereum to scale up to their real potential and to have a world-changing impact. So thank you very much. We have cool bounties for this weekend. So if you want to hack using our tools, please come to the booth and we'll be able to help you in any way we can. Thank you very much, guys.